Welcome to the Introduction to the WASP Graphical User Interface webinar series. This webinar is produced by the Water Protection Division, TMDL Development Section, EPA Region 4. The objective of this webinar today is just to tell you how to download the WASP model, give you a detailed overview of the WASP Graphical User Interface, basically take you through creating an initial WASP input dataset, executing the model, and then a brief introduction to the Moving Graphical Post-Processor. To download the latest version of WASP, click on the link above, www.epa.gov/Athens/WWQTSC. To install the WASP model, you will need to have administrative privileges on your WASP-based computer system. Okay, we'll now do an overview of the WASP Graphical User Interface. When you first come into WASP, there are only a couple of items that you can actually select from the icons at the top. The first one is you can create a new file, open an old file, or use one of the two post-processors to look at results from a previous run. So in our case here, we're going to create a new file. So we're going to click New, and now you'll see that several other items have popped up. We're going to go into this gear screen, model parameterization screen. This is a critical one that you need to do pretty much first whenever you create a WASP input file, because the critical thing here is you have to pick which of the model types you would like to set an input file up for. So you have the choice of our standard eutrophication model or advanced eutrophication model, which has everything that's in the eutrophication model plus additional algal groups, paraphyton, pH. We have a simple toxicant, a non-ionizing toxicant, organic toxicant, a mercury model, our heat model, which does water temperature and fecal coliform, and then our metal speciation model. So I'm just going to click the advanced eutrophication model. And once you click this and leave the screen, the user interface will be parameterized specific for this model type. So I'm just going to put a little description up here so I can remember what this is. In this field here, I can put comments in here as I'm building my input data set to specify notes to myself. The next critical step here is you have to set your start and end time of the model simulations. Now you can change this once you've built your input data set, but initially we're just going to need to set this to a time. If this time is not set, the other icons on the screens will not light up because it does not know what the time frame of your simulation is going to be. So you can see that there's two fields, month, day, year, and then hour, minute. And then I'm going to just put the end time in, so I'm just going to make a 1 year run. So that would pretty much take care of that. The other options that we have on this screen are setting the hydrodynamic, or how the flows are going to be calculated in the model. There'll be a little bit more about that in the flow lectures that'll be developed. I'm going to be using the 1D kinematic wave, which is going to allow WASP to calculate the flow through the system. I'm going to leave our solution type to Euler. There are a couple of other options. The cosmic option is used when you're linked to three-dimensional hydrodynamic models like EFDC. The Runge cutter could be used if you've got sharp diel variations that you need to be more stable around. I'm going to leave it as Euler. This screen over here for the time step options is you don't really get the option to set the time step in WASP. WASP automatically calculates the time step as a function of transport, loadings, and kinetics. The top one, fraction of the maximum time step, basically what that says is if WASP calculates a time step of 1 day, the model will actually take a 0.9 day time step. So this is a way for us to just throttle back the time step optimization. The maximum time step can be used to set, well, what is the biggest time step you want the model to take? So in this case, I don't want it to take a time step larger than a day. So in other words, if it calculated that the time step could be 3 days, it'll still take one time step per day. The minimum time step field is there to allow you to set the bottom to how low you want to let the time step optimizer go. This is a very, very small number that's there right now. That's 0.0001 days. So if it gets below that, it's going to stop. And once we're done with this screen, we're going to click OK. And now that you'll see that the rest of the screens are lit up. So the best way to work this is actually these icons going from left to right. So the next one I'm going to go into is just the printable screen. And this is just basically a time function of values to let you know how often you want to write simulation results out. All of the time series screens in WASP all look the same. There's going to be 3 columns: date, time, and a value. So for the printable, I'm going to have a steady printable of 4 times a day. So this is the start of my simulation, the end of my simulation, and I'm going to put in a value of here 0.025. So that means that as WASP is going through time, it'll use whatever the interpolated values are between the current time and the next time as the printable. So in this case, it's constant, 0.25 days. Okay, once we have the printable in there, we're going to leave this screen and we're going to continue on to the left. And the next one is the segment screen. There's several tabs in this screen that we'll talk about. The first tab is the segments tab. And what the segment tab is how we define our water body or break it up into segments to be considered with it. I'm just going to set up a simple 5-segment river. So I'm just going to hit insert down here 5 times, and you'll see that I've now created 5 segments in WASP. We can give the segments names. I'm going to call this the upstream. We'll call this the downstream. We can say that we got a wastewater treatment plant coming in here. This is where the I-20 bridge is at. And we have a monitoring station here. We could give these just about any name we want to. There is a limitation to the number of characters that you can have. The benefit of naming your segments is when you get over into the post-processor, you can actually, instead of trying to remember where your monitoring station is, it'll say in the description, monitoring station. Now the next thing is, for the volumes, we have to give some kind of volumes to this system. WASP is a metric model, so everything is in metric units, so volume is in cubic meters. So I'm just going to set these all to the same. So one of the tricks that we have in the user interface is if you want to set all of the columns to a single value, you just click on the header above it, it turns the column blue, and you just use this fill calculate. And I'm just going to set it to a fairly large number. So there's our volumes. The next thing we'll need to do is set the depths. I'm going to just set them to 1 meter deep. And then because we are using the kinematic wave, we do have to put lengths, widths, and slopes in here. So the other thing that will happen is whatever you put in here, it'll recalculate the volume. So I'm just going to set the length to 1,000. I'm going to set the width to 10. And then we can set a minimum depth. In other words, if the flows go away, this will be the lowest the depth will get. And I'm just going to set that to a small number. We need to put a slope in here. I'll put in a fairly gentle slope. And then a bottom roughness. So this is all the information that's needed for the kinematic wave calculation in WASP. So we've just defined our segmentation, or how we're going to break our water body up. So we have five segments. They all have the same volume. Now other things that are in the segment screen is we have these parameters, and we'll talk about these a little bit later, but this is where you set things for water temperature, water velocity, whether you have ice cover, if you have a time series for benthic ammonia or phosphorus fluxes. You would initialize the sediment diagenesis model here if you wanted to use it, and there'll be a separate lecture on the sediment diagenesis model later on. And set up any other segment-specific information that you would need to set in the input. The next screen is to set the initial conditions for any one of the state variables. Typically, when we're using the eutrophication model, we don't set initial conditions. But if we're using the toxicant model, initial conditions are critical. So initial conditions are basically the mass of whatever state variable that you're looking at is in each segment at the start of the simulation, so we can continue on. And then the fraction dissolved, you could use this to determine how much of a particular state variable is in the dissolved or particulate phase. For the eutrophication model, the advanced eutrophication model, these typically all state of 1. If we do have sorption for ammonia or phosphorus, it would be calculated by the model. So we're done in the segment screen. So we're going to click out of here. And the next screen we're going to go into is basically like the master control panel for turning equations on and off in WASP. It's called the system screen. So in this screen here, we have a list of all of the state variables that are in the advanced eutrophication model. As you can see, there's 28 of them. Now, if you weren't going to be using some of these, you would want to shut them off. And the way we shut them off is, so in our case here, we're not going to be doing benthic algae. So I'm going to come down to line 18. I'm going to say, let's bypass it. So we're going to bypass everything that has anything to do with periphyton. And basically, that shuts off the periphyton equations in the model, so the model doesn't even make the calls to those routines. So it saves runtime for you. Other things that are in here, if you did specify a fraction dissolved less than 1, you would have to say which one of the solids transport fields you would use to move the particulate fraction. And we'll talk a little bit more about that in the solids lecture. The last thing I want to point out in the system screen is this column called maximum concentration. And in here, this maximum concentration is the highest value we would ever expect one of these state variables to be in the natural environment. And if WASP calculates a value that's greater than this maximum concentration, it assumes that the model is going unstable and it shuts down. So in the case here, if you were doing solids, you probably would want to increase this 100 to something larger because, it is possible to have a concentration greater than 100 for solids, so you would increase it, otherwise it would shut down. The scale factors that are out here to the right, we'll talk about later. You can also see them in another screen. Okay, continuing on, leaving the system screen, we're going to click OK. We're going to go over to the next screen, and I'm going to just show you this. We're not using this functionality yet, but this is a parameter screen. If you remember from earlier when I was in the segment screens, there was a parameter tab on the segment screen. If I had entered information over here in the parameters, such as if I wanted to just set my water temperature to 20 degrees, I could just come in here, temperature of the segment, I'm going to set it to 20 degrees, and what that does is for each segment, when the model runs, the water temperature will be 20 degrees. Or if you actually use the time function, you can change it through time. But putting this value in here doesn't actually get the information passed to the model. You have to come over into this screen here and say, okay, I need to turn this on. And you'll see this function in the interface many times over used. So in other words, even though I put the value over in the parameter screen, if I don't click this X over here, the information is not passed to the model when it runs. So it's critical to make sure you come in here and you set that. The other thing that you'll see in here is you have a scale factor where you can scale any one of the parameters globally for all the segments. So all I'm doing is turning on segment temperature. I'm going to click OK. Now the next screen we're going to go into is the kinetic constant screen. And this, depending upon the model type, this changes. But what you'll see here is we've broken these things out into constant groups. So for the advanced eutrophication model, we have things like global, inorganic nutrients, partitioning, organic nutrients, the BOD field, dissolved oxygen, the sediment diagenesis model, the light model, solids, benthic algae, periphyton 1, 2, and 3. Now, the only thing I want to just say about this is, because we're not going to set anything yet, is that just like the parameter on-off, for any of this information to be passed back and forth to the model, you have to turn it on. So you'd have to click on a button, click on use, and then type in a value, and then that information would be sent to the model at runtime. Okay, so let's moving on. We're going to go to the loading screen. The loading screen allows us to designate a mass loading to any one of our segments for any one of the state variables in our system. So if I open up this tree here, we can see the different state variables that we have available to us in the advanced eutrophication model. So if I wanted to have an ammonia load, I would highlight ammonia, right mouse click, and then say add remove loads. And I'll say, okay, I'm going to put an ammonia load in at wastewater at segment 2 where the wastewater treatment plant is at. I'll say okay. You'll see now that there's a plus sign here. I would open this up, click on that, and you'll see that we have this time series value down here again. So we can put in time series. Now, one of the things that needs to be corrected in the interface is under loads, under the state variable, it says ammonia nitrogen, milligrams nitrogen per liter. Well, loads are not in concentration, they are in mass, and they are in kilograms per day. So over here we're going to enter a kilogram per day of ammonia, and I'm just going to put in a relatively small number here, 0.01 kilograms per day of ammonia. And then I'm going to say OK. So that's how the loading screen works. And coming back in here, you can always go and add other loads in other places. All right, the next screen is the time function screen, and this is for putting things into the model that can vary in time that aren't simulated by the model but can influence the calculations of the model. So for the advanced eutrophication model, you can put in 4 time series data of water temperature that you can assign each one of these functions to a different segment, and you do that back in the segment parameter screen. Solar radiation, whether it's measured or it's calculated externally or brought in, you bring that in as a time function. The fraction of the day that is light, and we'll talk a little bit more about that in the eutrophication lectures. Wind speed. You can have 2 wind speed functions that are used for reaeration. You can have a light extinction time function if you're not going to let the model calculate it. Air temperature, water velocity, phosphorus and ammonia benthic fluxes, ice cover functions, a shading function, zooplankton population function, reaeration function, time variable settling rates for the algal groups, and then a varying CO2 atmospheric pressure that would be used in the pH calculations. And again, these time series work exactly the same. So if I was just going to put in a wind speed function, I would just come down here and I would say, okay, the wind speed is 0.5 meters per second. I can actually insert another one, and I can change this from day to day, or I can go from week to week, and I can allow the model to interpolate as it goes through time these values. At the end of this section, you'll get a introduction to how you can bring in large amounts of data from spreadsheets, databases into the WASP interface. So that's basically how this works. And again, you have to click the use function, or that information will not be sent to the model. The next screen is the dispersion screen, and this is where you have a dispersive exchange between the segments. For our river system, we're not going to enter any dispersive exchanges, and we'll talk about this later in the dispersion lecture. The next one is flows, and we are going to enter flows here. Now, when you're using WASP to do the hydrodynamics, you pretty much have to tell the model where the water is coming from and where it's going to. So there are 6 flow fields in WASP: surface water flow, water flow, 3 solids settling and resuspension fields, and then evaporation and precipitation. We're just going to use the surface water flow field, so I'm going to click used here, and then I'm going to go over to the right and you'll notice that this box comes in here, and I have to insert a flow function, and this is just going to be my main stem flow. I don't have any other flow functions that are coming in here, and then I'm going to go down to the lower left. I'm going to hit insert several times because now I have to route the water from where it's coming from and where it's going. And there'll be more about this in the flow lecture as well, but I'm basically starting upstream from outside the system, a boundary, to segment 1. Segment 1 goes to segment 2. Segment 2 goes to segment 3. Segment 3 goes to segment 4. Segment 4 goes to segment 5. And then ultimately 5 goes to the boundary. So the next thing we would do is we'd have to put a flow in here. And I'm just going to put in just a steady flow for right now. And I'll just make it 1 cubic meter per second. So basically we turned on a flow function, a flow field. We had our flow function, and we can have up to 50 of these flow functions. And then we route the water through the system, and then we give it a time series of flow. Alright, once we're completed with the flow screen, we're going to hit OK. Well, now we're going to move on to the boundary screen. The boundary screen defines where water is flowing from outside our model segmentation to inside, and from inside our model segmentation to the outside. So this is where we put the concentrations of water that are coming in from the outside. So much like the load screen, the boundary screen has this little tree that you open up, and you'll see each one of the state variables there, and we can enter a time series of concentrations for each one of the boundaries coming into the model network. Now WASP determines which segments have boundaries on them as a function of how they're defined in the flow and the dispersion screen. So anywhere in the flow screen or the dispersion screen where you say you have something that says boundary to a segment or a segment to a boundary, you'll get an entry into this screen here. If you come into this screen and you see a segment that you don't believe there should be a boundary associated with it, you need to go back and look at those two screens to determine where the mistake was made. So for our simple case here, we're going to just enter an ammonia boundary concentration at the upstream boundary. So I'm going to just click on, I'm going to go to ammonia, click on upstream, and I get this time series, just like we see everywhere else. And I'm going to set the values to 1. Boundary concentration coming in is 1 milligram per liter at the boundary. So with that, I'm done with this screen. I'm going to say OK. The last screen that I want to show you is the output control screen, and this basically allows you to say which one of the output variables you want written to the simulation result file, which has an extension of BMD, which stands for binary model data. And in this case, we have them all turned on. And I'm just going to leave them all turned on for now. When you start getting into production runs, you may only want to turn on the ones that you're simulating or the ones that you really need to investigate. You'll also see there's an option for creating a comma-separated value file. So if you click this option on, it'll create a CSV file which will have all the predictions for that particular output variable through time for each one of the segments. I should caution that if you have a large network and you use CSV files, the model performance will be diminished drastically because it takes time to write these files. It's much quicker to use the other functions for output, basically the BMD file. So we're going to leave these all turned on. Now we're going to just go over and we're going to save our file. We have to pay attention to where we save this thing and make sure that you give it a name. So in this case, I'm just going to call it example, and I'm going to save it. And up at the top here, it'll tell you where your WIF file is located. WIF stands for WASP input file. Your little description that we typed in earlier and what model type it is. So with this, we have successfully built a WASP input data set, and then in a moment we're going to execute the model. Okay, with the file saved now, we can go ahead and run our example input file. To do that, we're going to click on the icon that looks like a WASP, and it executes the model. And what happens is, when you hit that run button, it loads the appropriate model type. In our case here, this was the eutropyrophyte and multi-algae model, the advanced eutrophication model. And as it's running, it displays information to the screen. Down here where you see a yellow circle with a question mark in it, that meant WASP encountered a value that was not set in the constants or the parameter screen, but yet it needed to have a value so that it could make the calculation. And it kind of protects us from divide by zeros or calculations that go to infinity. So these are default values that were set to make the model run. And then ultimately in the end, if your model ran successfully, you'd get this little model runtime performance screen down at the bottom that basically says that it completed. So we've completed our initial run. Now the WASP output gets saved to whatever your input file name is, but has the extension BMD, binary model data. So in our case here, it's example.wif is the input file, so our output is going to be example.bmd. It's going to be in the same directory wherever the WIF file is at. Now there are some neat functions in WASP that will allow you to load an output file quickly, and that's using the project function. And I'm just going to add to this project the output file so that we know. So I'm going to click on project on the menu up at the above. There's not an icon for this. I'm going to say edit project. And what I'm going to do is I just want to relate files to this. So one of the first ones, the file I'm going to relate is actually my BMD file. And you'll see that it's listed here in my directory where the WIF file is at. And you also can tell it's a BMD file because it has this icon that's associated with it, and the file type is Move'em, which is the WASP post processor. So I'm just going to add that to this project, and you'll see later on that there are other ways to add other file types to this thing to make it be more useful. I'm going to say OK. Now the project information is actually saved in the WIF file, so before we can actually use this information, we need to save the WIF file one more time. Now we'll click on the first post processor that's available for WASP, and it's called Move'em. The second post processor, well, the icon says CBIOM. It's actually now linked to the Water Resources Database graphing program. And it's only linked to that if you've installed WRDB on your computer. So, and we'll talk about that in a separate webinar. So let's just go ahead and create a couple of output plots of the WASP results. So I'm going to click on post process. And you'll get this file. This will pop up every now and then. Could not load a specified file. It's looking for a file that is no longer supported in the current versions of Windows, but that's fine. Once you get there, you'll get a screen that looks like this, and you'll see that up at the top there's this. You can either open another file or you have this icon here. This icon here allows us to create plot files, and plot files allows us to create a time series graph, an XY plot of any output variable that WASP wrote during the simulation. And you build these graphs one line at a time. So you're basically going to define what you want, and then it shows up on the screen. So to define a line, we're going to just hit Add Curve, and now you'll get a screen that looks like this. And you'll see that we have data sources. If you had more than one WASP output file loaded, they would all be in here. You'll see that these are the variables that you can output from, you could plot from the WASP output. These are directly related to what was turned on in the output control icon that we looked at earlier. So what I'm going to look at first is I'm just going to plot temperature. And I'm going to just plot it at segment 5. And this is basically just going to give us a time series graph of temperature. So I click OK, and there's my graph. And if you recall, under the segment parameters, we set the temperature to 20 degrees. And as we can see in this graph here, it is 20 degrees for the whole year. The next thing that we might want to plot is flow. And what we'll do is we're going to plot flow at all of the segments. So again, I'm going to hit create a new graph. By the way, there's no limit to the number of graphs that you can create. So I'm going to add curve. I'm going to go to segment 1, and then I'm going to go segment outflow. So there's my first curve. So now I'm going to add the second one for segment 2, segment 3, segment 4, segment 5. So now when the graph creates, I'm going to get a time series of the outflow from segment 1, 2, 3, 4, and 5. So there'll be 5 curves on the graph. I click OK. So here are my curves. If I just zoom in here, I can see the flows. Here's the flow in segment 1, going to 2, to 3, to 4, to 5, until ultimately we get to the 1 cubic meter per second flow that we entered. The last thing we're going to do is we're just going to plot the ammonia concentration, and again I'm just going to do it for segment 3. Some handy things to help you jump around in here. You can search by clicking up and down, but if you actually type the first letter of the output variable, it'll jump to it. So here is ammonia at segment 3. And again, it started at 0 because we had no initial conditions, and it made it all the way up to 1 milligram per liter. So that's some of the functionality of the post processor. See other webinars for more detailed uses of both Move'em and the WRDB graphing tool. Okay, that gives you a brief overview of Move'em. We're going to move back to WASP, so we're going to just close this program. And it's important to realize that if you make a subsequent run of WASP, you need to make sure that the post processor was closed and you reopen it to reload the new BMD file. Before we leave here, the last thing that I want to show to you is if you click on the Help menu item, you'll see several things here. The first one is the About box. Yeah, it gives credit for who did what, working where. But the big thing that we want to look at here is under the components. When you click on this, it says what the current version numbers of each of the DLLs that you have installed. So this is always a good place to make sure that you have the most up-to-date version of WASP. Lastly, you can access all of the WASP documentation. It's all available from the documentation tab. It's all installed with you. Release notes for anything new, documentation, how to use the user interface, a lot of detail in a lot of stuff that I just showed you, documentation for the stream transport, the multi-algal model, the temperature model, the mercury module, simple toxicants, some details about the pH alkalinity model, a basic WASP user's manual, documentation for the heat module, a description of the non-point source file format if you're planning on using that, and then you have 2 links to two websites. One is just the WASP technical support website, which is maintained outside of EPA, and then the link to where you download WASP from the Water Quality Modeling Technical Support Center. With that, we're done with the introduction to the WASP interface.